Assalamualaikum and hi everyone. In this video, we from Group 1 consisting of Aris, Arif and Faris will be presenting on hydropower plant analysis. Before I start on the hydropower plant analysis, let's take a look on our table of contents for this presentation. First, we will start with an overview of hydropower and its importance. Next, we will explain how a hydropower plant works, focusing on its energy conversion process. Then, we will look at the concept of gross head and its role in determining energy output. After that, we will discuss the losses that occur during energy conversion and their impact. We will also examine the factors influencing the efficiency of a hydropower plant. And finally, we will summarize the key points of our presentation. So let's begin with the introduction. Okay, first, what is hydropower? Hydropower is one of the oldest and most reliable renewable energy sources. It is a form of renewable energy that harnesses the energy of flowing or falling water to generate electricity. Hydropower also offers a clean and sustainable alternative to fossil fuels. The key advantage of hydropower is its ability to produce large amounts of electricity without releasing greenhouse gases or harmful pollutants. It also provides energy on demand, as the flow of water can be controlled to match electricity needs, making it highly flexible and efficient. In a world that is currently reaching for sustainability, hydropower is a technology for reducing carbon footprints and ensuring energy security. So this is the simple illustration of a hydroelectric power plant. It is located at a it is usually located at a reservoir or a dam, and hydroelectric power plant consists of components like turbine, generator, and transformer. Moving on, a hydropower plant converts the mechanical energy of moving water into electrical energy through a series of steps. So for the first one, water flow and potential energy. The process begins with water stored at a height which gives it potential energy. As water flows down through the penstock, its potential energy is converted into kinetic energy. The high pressure water spins the blade of a turbine, converting the kinetic energy into mechanical energy. Then, the turbine is connected to a generator via a shaft. The spinning motion of the turbine causes the rotor inside the generator to rotate, and as the rotor spins, it creates a magnetic field, inducing an electric current in the stator through the process of electromagnetic induction. This process is highly efficient and highlights how the natural flow of water can be harnessed to generate clean electricity. Now, let's look at the short animation video for the hydroelectric power plant. Now, let's look at the short animation video for the hydroelectric power plant. Now, let's look at the short animation video for the hydroelectric power plant. So, lastly, the equation for the mechanical energy of a flowing fluid on a unit mass basis is equal to P over rho plus V squared over 2 plus Gz, where P is equal to pressure, rho is equal to fluid density, V equal to velocity of fluid, G gravity acceleration, and Z is the elevation or height in meter.
Gross head. The gross head is the vertical distance between the water source like a reservoir and the point where the water flow out through the turbine. This height difference create a potential energy in the water, which is converted into mechanical energy by the turbine. To put it simply, the greater the gross head, the more energy the water has to drive the turbine. For example, in a high head hydropower plant, even a small flow of the water can produce a significant amount of energy because of the large height difference. Otherwise, low head plant rely on a higher flow rate since the vertical drop is small. It because it need to create as much as possible energy by flow rate of the water instead of potential energy by drop of the water. The design of the gross head play a crucial role in determining the output of hydroelectric power plant. It depends on how many capacity need to supply by this plant and how far is transmit to the user. Now, let's talk about the irreversible power loss. Not all the potential energy in the water is converted into useful energy. Some energy is lost due to factors like friction in pipe, turbulence, and inefficiency in the turbine. These losses are called irreversible power loss because they can't be recovered. For example, As the water flows through a long pipeline, friction with the pipe wall slows it down, reducing the energy available for the turbine. Similarly, if the turbine blades are not perfectly designed or maintained, some energy is wasted as a heat or noise. Designing a hydroelectric power plant requires careful consideration of several key components. These include the design of the piping system, the selection of appropriate pump, and the type of turbine used, or even the hydraulic analysis is needed for precise output calculation. The efficiency of the entire hydroelectric power plant is significantly influenced by proper functioning and interaction of these elements. Next, in Malaysia, there are several large-scale hydroelectric power plants with the Bakun Hydroelectric Plant in Sarawak by Sarawak Energy being one of the most prominent with a maximum water level of 236.5 meter above sea level. This plant boasts a significant capacity ranging from roughly 2,400 megawatt to 2,700 megawatt and has an estimated head of 116 meter. Following Bakun, the Baleh Hydropower Plant in Sarawak holds the position of Malaysia's second largest hydropower plant, capable of generating substantial 1,300 megawatt of electricity. Other than that, the plant like at Negeri and Labir plant, both at Kelantan, and there are many more hydropower plant in Malaysia and make it hydropower plant as a second most contributed to supply electricity in Malaysia. Is of course after coal and gas.
Next, we want to discuss about the hydropower plant efficiency. So, efficiency in hydropower plant refers to the ratio of the useful electrical energy output to the available mechanical energy from the water flow. So, from the equation here, we can see that efficiency is equal to the electrical energy output over potential energy input over 100. So that we will get the efficiency of the power plant. And so why efficient is matters for the hydropower plant? Because it determines the performance of the power plant itself, and also is minimizing the energy losses and also ensuring the cost effectiveness. Next, we want to see the factors affecting the efficiency. So the first one is the gross head. Gross head is the height difference between the water source and the turbine effect will affect the potential energy available. And the next is the flow rate, which is the volume of water that passing through the turbine that will influence the energy generation. And the third one is the turbine efficiency, which is the mechanical losses in the turbine that will reduce the overall efficiency. And the next one is the generator efficiency, that we will see the conversion of the mechanical energy into the electrical energy that will introduce the electrical losses. And the last one but not least is the irreversible losses. It's a friction, turbulence and heat losses that that reduce by the energy available of the conversion. Next, we move to the conclusion. So efficient hydropower plants are vital for meeting energy needs while promoting clean and sustainable solution. Efficiency determines performance, and it reflects how effectively a hydropower plant convert potential energy into electrical energy. The key factors that will determine the efficiency of the power plant will include crosshead and also the losses. Proper design and minimizing the losses like friction and turbulence will enhance the efficiency of the hydropower plant. And lastly, the improvement lead to sustainability, because modern technology and also the maintenance will optimize the energy output and will reduce the environmental impact. Thank you.